Yeah, hello dear students. Today's lesson is multiples, factors, and primes. You can find it from page 11 to 14. I combined two sections, 1.2 and 1.3, because they are related very much together. As before, the objective is a definition about what we are speaking about, an example, and then we go to exercises in page 14 and in page 20. So, definition of multiples. What are the multiples of a number? If I say to you, I want to multiples of 4, that means I multiply 4 by 1 to 6, I can go on. 6, 7, 8, 9, 10, 11, but you are limited to what I want from you. For example, if I tell you, find me the multiples until you find the least common multiple between this number and another number. So you go on multiplying by 1, 2, 3, 4 until you find a number result here which is equal to another number in another number, multiples from another number. Then you stop, and we shall see that in the exercise. So the multiples are multiplying. 4 times 1 is 4. 4 times 2 is 8, 4 times 3 is 12, 4 times 5 is 20. These are the multiples. These 4, 8, 12, 16, 20. These are the multiples of 4. These are the multiples of 4. Okay. What about the factors of 6? Factors of 6 is the numbers which can be divided by 6, but they leave no remainder. So 6 divided by 1 is 6. Is there a remainder? No. 6 stays as an integer, or you can call it as a whole number. Everything is okay. And by the way, 1 is a factor for all numbers, because you can divide any number by 1, the number stays the same. We go to the next number, 2. 6 divided by 2 give me how much? 3. 3 is a decimal? No. Is a real number, is a whole number. Okay, then it is a fraction. 2 is a fraction. 6 divided by 3 give me 2. So 3 is also a factor. A factor. Because 6 can be divided by 3 and it gave me a result of 2, and 2 is an integer. Or you can say it is a whole number, a real number, not a decimal, not a fraction. So 6 divided by 6 give me 1. What is 1? Is it a decimal? No. Is it a fraction? No. So it's a number. It's a real, correct, whole number. So when this number, except dividing by other numbers, giving me a result without a remainder, that means this number which I divided upon is a factor of that number. So 1, 2, 3, and 6 are the factors of 6. Okay, and then we can find this in another way. It's called the factor tree. I gave 2 examples now. 6 is coming from 2 multiplied by 3. Okay, or you can 6 can also come from 1 multiplied by 6. Okay, this is called factor tree. But most mathematicians, they don't care about this one here, because they say 1 is a factor for all numbers. So what's important is this one here, 2 multiplied by 3. So the factors, in fact, you can say, if you tell me that the factors here from 6 is 2 and 3, I couldn't say wrong. No, it is true. But 1 and 6 is not very, by most mathematicians is not, they are factors, but they are taken not very, the real definition of factors of a certain number. So you can say here, I have only 2 and 3 as factors for number 6. This is not finished until now. 6 can be defined, you see, into 2 and 3. So this 6 also comes, you cannot stop by 6, because 6 is still is made of 2 Bausteins, 2 Lego objects, which are 2 and 3. So 2 times 3 is 6. So this is finishing, you see, at the end is the factors is only 2 and 3. You can mention 1 is okay, I don't say wrong, but it's not very important. Important is 2 and 3. As I said, most mathematicians, they don't think as 1, because it's a factor for all numbers. What is the prime numbers? The prime numbers, these are the prime numbers, 2 and 2 and 3 and 1. What about them? They accept to be divided by themselves, like 2 over 2 equal 1, or divided by 1, 2 over 1 equal 2. Otherwise, no, they will give me something else. They will not give me a real number or an integer. They will give me a decimal or something like that. Look, So these are the prime numbers. Any number of these, any number 7, 11, 13, 17 can be only divided by 1, like 17 divided by 1 is 17, or 17 over 17 is 1. That's all. Only in this case they will give you a whole number or an integer. What happens if I say 17 divided by 2? It will give me a decimal. What I say when I say 17 divided by 3? It will give me a decimal. If you don't divide these by 1 or themselves, they will give you a decimal. So the prime number is a number which accepts only to be divided by itself or by 1. Exercise 1.2, page 12, I took 15. A. Find me a number which made from two factors, from factor 2 only. So if you're looking for a number which is made from a factor 2, write down 3 numbers whose only prime factor is 2. So they want you to write 3 numbers which only prime factor is 2. Also the prime factor must be not 3 or 5 or 7 or something like that, only 2. And he wants for me to write 3 numbers. So this is the numbers 4 and 8 and 16. You can take 2 and 2. 2 by 2 is 4. 4 has only prime numbers 2 and 2. You multiply them 3 times, give you 8. So 8 is the number which are made from 3 prime numbers which are only 2. Or you multiply 4 times the 2 and it gives you 16. So 16 is the third number which its prime numbers are only 2's. Why is that? Because at the base of each number of these, as I told you, or any other number bigger than 1 which is not a prime number, the base, the Lego stones are always small prime numbers, collected together. So every number bigger than 1 and it is not a prime number, at the base of it, it's a collection of Lego stones which are prime numbers, 2, 3, 7, something like that. All prime numbers. You wouldn't find 4 or 6 or 8. No, all at the base of the pyramid, they are all prime numbers. So the answer is 4, 8, 16. This goes also for B, I think. This is the factor tree, 16. 2 by 8, 8 is 2 by 4, and then 4. You see, every time, when you reach a prime number, you can do nothing more. But if you reach something not prime, it will be divided into 2 other, Lego stones. This one is a Lego stone, this one is not yet a Lego stone, because it can be divided into 2 Lego stones. They are 2 times 2. So the 16 made of these 4 2's, which are the Lego stones, 2, 2, 2, 2. Only they are the base of the 16. The same goes for B. The same goes also for C. He wants here a number which is only made from 3 numbers which are made only from 3 as prime numbers, or he needs numbers which are only the base from 5 from 5. You take only the 5, multiplied by itself, it will be 25. 25 is a number which have 2 Lego stones, 5 and 5. 125 have how many? 3 Lego stones, and this number have 4 Lego stones named 5. So exercise 1.2, find a number bigger than 10 that has an odd number as a factor. A number bigger than 10 is 11. And has you multiply 11 by 11, give you 121. So 121 now have a factor as an odd number, as 11 is an odd number, not an even number, and it is a factor of this number 121. In fact, we have 2 of them, 2 odd numbers which are building the base of the number 121. So we go now to find a number that is 3 prime factors. He didn't say what type of prime factors are there, but anyway, he said I need 3 of them. You take any 3 prime. You take 11, you take 13, 17, multiply them together, it gives you this number. So I can say that this number is at the base of the pyramid, made from these 3 Lego stones, 11, 13, and 17. These 3 Lego stones It was always prime, always prime. Whatever you put here, it's always prime, and this will give you this number here. Okay. Now 17, number 17. Find a number that has 3 prime factors. I think we've done that. Okay, this is a number of 3. Again, find a number with 3 prime factors. Take any prime factor, which is 3, 5, 7. You like to take 2, 3, and 5. You like to take 5, 7, and 11, as you like. You multiply them together, it will give you a number. This number is made at the base of the pyramid from these 2, 3 Lego stones. Find a number that has 3 prime factors, and they are prime factors. Important are prime factors. You don't multiply like 4 times 8 times 10, because 10 and 4 and 8 are not prime numbers. Okay. And this is the tree again. This is the tree again for 105. It is made from, you divide it by 3, it give you like 3 times 35 will give you 100. 35 is multiplied by 5, 7. Now 3 is here a prime number. I cannot divide it. I cannot make division anymore or split it anymore because it's a prime number. 35 can be splitted, and it is not a prime number, 35, because it's except to be divided on 5, give me 7, or 35 divided by 7, give me 5. 5 times 7 give me 35. So I have to split it again. Now I have the prime numbers. Now I have the Lego stones, 3, 5, and 7. These are my Lego stones, which are building the base of the pyramid, leading me to the end number, which is 105. Now we go here for 2 times 3 times 5 times 7. These are the Lego stones for the number 210, and the tree will be like that. You divide it by 2. You start to divide first by 2. If it doesn't accept, you go to 3, and so on. Always start from 2, 3, 4, 2, 3, 4. So 10 divide by 2 will give me 2, and this is a Lego. This is a Lego stone. I cannot divide it. This is not a Lego stone. I divide by 3, it will give me 35. Okay, you see it's here. The same small tree, the sub tree here will come here again. 7 by 5. These are the Lego stones. Now, sorry, these are the Lego stones, 2, 3, 7, 5, and they are all prime numbers. They are all what? Prime numbers. 2, 3, 7, 5 are prime numbers, okay? Going down the tree to the prime numbers, and 35 and 105 are not prime numbers because they accept it to be 105 except to be divided by 3 and leave no remainder. 105 except to be divided by 35 and it will leave no remainder. It exactly goes for the 35, okay? Now, for example, 1.3a, he wants from you to copy and complete each of these factor trees. 48. Okay, 48, as I said to you, start to divide by 2, it will be 24. This is a prime number, you cannot do nothing anymore. But this one is not, it can be splitted also, and the 12 can be splitted also. These are your prime numbers, okay? These are your prime numbers, 2, 2, 2, 2, 3. 24 and 12 and 6 are not prime numbers because they accept to be divided by 2 and leave no remainder, and 12 also. 12 is not a prime number. 6 is not a prime number because it can be divided by 2 and 3 and leave no remainder. So this is the tree, okay? This is the tree. You can draw it in this way, okay? Or you can start from 48. You can start from 48 and you can say from here 4 times 12, 4 times 12, and the tree will look something else. But at the end, they must give you, at the end, if you like to know if you are correct or not, they have to give you the same Lego stones, which are 2, 2, 2, 2, 3, 2 times 2 times 2 times 2 times 3. Or you can write it another way, 2 to the power how much? 1, 2, 3, 4. 2 to the power 4 multiplied by 3. This is another way to express the mathematical equation of this tree, which is called a factor tree. Okay? I want you, as I said, to learn the square root from 1 to 20. I hope you have done it, and make the exercises 1 and 8, page 14. Okay? Thank you very much for your attention.